A few of these off the back side here, so I don't mind going through and making sure you guys are feeling comfortable. We'll do a little bit of practice with some of these a little bit more today as part of our work. And then just so you guys know, we are reviewing, so we'll quiz on 2.8 probably on Wednesday, I'm thinking. Because 2.8 by itself, we're just making into its own like little chapter quiz type thing. So we'll review with that tomorrow. But
is it summative or?
it's a summative, but it'll be worth less points than
Okay.
I'm thinking. I think they should be. So yeah, we'll look at that. Because like we've had 2 summatives so far, I think, and those have both been around like 40. We'll probably keep it less than that, but then that allows you to retake it too. So that's a good thing as well. And if you guys are still thinking about retaking the last test, I am working on the retake. I didn't get it done for today, but thankfully no one came in to retake it today. I hope to have the retake for the last one done tomorrow. So, guys, so let's go through the questions you had on this. Starting with number 9. So we'll go through these and make sure you guys are feeling better about it if you weren't already. So in number 9, they give us the cosine, and they tell us something about the sine. Okay, so if they give us this information, we kind of use this little acronym to help us with this, to tell us which quadrant we're in. And they're telling us the cosine is negative, but the sine is also negative. This is telling us where these things are positive. So they're all positive in this quadrant. That doesn't work. Sine is positive in this quadrant. That doesn't work. Cosine is positive here, so it has to be in the tangent quadrant. So I'm going to draw the triangle. I'm going to draw it here, just a little bit bigger. Now I don't know the angle, but I always know the reference angle goes back to the axis. Like it's almost like it makes a little like bow tie, if that's helpful. They're always going to look like that. Now when I do this, this is my A over my H, because it's cosine ca. So if this is my angle, my A over my H, adjacent over hypotenuse. However, since I'm in this quadrant, I had to go negative, I had to go to the left, so that makes this negative. And then I'm able to find this side because of Pythagorean theorem or special right triangles, because this happens to be an easy side to find if you know your special right triangles. If you don't or you're not sure, you can always do Pythagorean theorem. So we're going to find this value. I'm going to call it y because it's up and down. So I'm going to do y squared plus a negative 12 squared equals 13 squared. Now careful, when you square something, it ends up being positive. I'm going to move this over. So y squared ends up being 25, so that means y is 5. And like I said, that's just one I knew because of the special right triangles. It comes up quite a bit in trig. This y is 5, that's here, except it's going down, so that's going to be a negative 5. Now why that's important is because that's going to allow me to find my other 2 trig ratios I don't know or don't have written here yet. So I need the sine and I need the tangent of that same theta. So sine is so, tangent is toa, and so now I'm just setting up those ratios. So sine is opposite over hypotenuse, and it makes sense it should be negative because that's what they told us here. And then tangent is opposite over adjacent, but then that'll become positive 5 over 12 because of the fact they're both negative. So getting yourself in the right quadrant and then finding the other side you didn't currently know. That was number 9. Number 10 and 11 are similar, so if you struggled with 10, hopefully 11 will make a little more sense to you or help you out a little bit with that, but let me know if you still want some help with 10. Oops, I went a couple pages here. So number 11 says the tangent of theta is 2 and sine this time is positive. So the tangent's positive, the sine is positive. they're all positive. They're all positive, so we're in this quadrant. I don't know why I crossed the other ones out, I guess doesn't make sense. But so I need to draw my triangle here. Now tangent is TOA. Now 2 isn't a fraction, so I'm going to put the 2 over 1. Same thing in number 10, you should put that negative 1 over a 1 if you're wondering about how to do number 10. So that means in this triangle, my opposite is 2, my adjacent is 1. Now you might immediately think 2 and 1, oh then the other one has to be square root of 3. But that doesn't work because of the fact that this is the hypotenuse, not the like middle side. So we're going to solve this. So h is the square root of 5. And so that's our hypotenuse that we need for sine and cosine. So sine is opposite over hypotenuse, so 2 over square root of 5. Now I can't leave that square root in the denominator. Now if you did it this way, like on a problem that's worth a bunch of points, you'd only lose a small fraction of the points, but obviously you don't want to have to lose any. So you multiply by the square root of 5. So this would be considered simplified. And then cosine adjacent over hypotenuse. So same thing there. Great, questions? All right, so then going to number 12. Number 12 was rough because the radical was hard and you could simplify it and you might not have realized you could. So I would totally understand if you got this one wrong. So again, we're still in the first quadrant because sine and tangent are positive. Those two are positive. Cosine's automatically going to be positive as well. So that means we're in the first quadrant. This is my O over my H. So my opposite is 5, my hypotenuse is 7. So I'm looking for a little a here. Now in this case, when I go to find that, like I said, it ends up being not a very nice number. Oops, that should be 7 squared. I got ahead of myself. So if you didn't realize, the square root of 24 can be simplified. I'm okay if you guys leaving it that way. At the same time, just know going forward, the more you can simplify these radicals, the better. 24 breaks up as the square root of 4 and the square root of 6. One of my answers might be wrong now that I say this, so we can double check this. So this would be 2 square roots of 6 would be A. Like I said, I think I might have done this wrong on one of them, so I think it should be, yeah, 2 square roots of 6 over 7 maybe. I'll fix that. But so here's my A. So you could either have it one of these two ways. So if I want the cosine, you could have just square root of 24 over 7. Or like I said, I think I did write this wrong. It should be 2 square roots of 6 over 7. Either one I'm fine with. They're equivalent. The second one is technically a little more simplified, but it doesn't really look like it, so it's okay if you did not do that. Now tangent's a little bit more of a tough one because it's opposite over adjacent. So this is one way you might have it. So 5 square roots of 24 over 24. Now this answer is okay. However, what we prefer to do is have simplified this and then just multiply by the square root of 6. So my simplified answers were wrong. So that's the better answer, but that one's pretty strange. So sorry, that shouldn't have been a tough one like that. All right, and then number 16. Oops. In number 16, they said if the cosine of theta equals 0.208, they want to know where could this happen, find all angles that could represent that theta. And I guess I'm just talking about like in this very first set of coordinates. So all students take calculus. It's going to be one of these two, or both of those. So if I know what the cosine equals, I can do inverse cosine. But this is only going to give me one answer. So you'll do inverse cosine of 0.208. And I get 77.99, so I'm going to call that 78. So that would be here. That'd be a 78-degree angle. However, get that same answer is also in that C quadrant. So down here, this angle as well would give us the same thing. But I have to measure it going around this way. So I'm going to basically do 360 minus 78. And I end up with 282. And if you check that, if you check the cosine of 282, you'll get that same value. So it's the same ratio that you get in either spot. So you want both answers there. All right. Questions at all? All right, so this, yeah. If you added 360, okay, so yeah, technically, but we could keep doing that then, so this could be like some sort, and so actually later on when you guys, if you do this technically, you would have to like add an extra little piece onto that. I'm saying let's just go in the first cycle. But yes, that would, so what Trey's saying, couldn't we just keep spinning that? Couldn't we go 360 again, same angle, 360, yeah. But we want in this very first snapshot, how many? But yes, technically you keep doing that forever.
The video from Friday come out just before you guys.
Yeah, and I like, yeah, Friday's video was a mess, I'm sorry. That was me still like not being fully.
Oh yeah, that was
Right. So yeah, I went and looked and I'm like, I don't think it's recording, and then I
and then you
stopped.
stopped.
And then it was recording, and then I like looked and I saw there was a video, so I'm
And
sorry.
then I texted Maddie, I was like, I think the starting you thought she wasn't recording.
I was like, I'm so stupid, and then here it was like,
So the 1.5 part was the same last 6 minutes of the other video.
oh yeah, I don't know. Sorry. Thank you for being patient with me. That's why you have to take so many takes when people do stuff on TV, is because it's not as easy as it looks. This is me in one shot here on cold medicine. So, let me get you guys today's notes. So it's our last day of new notes. We're going to launch your graphing calculator today. Now for the warm-up, I want you guys not to use your graphing calculator, so don't do your graphing calculator for the warm-up. Oh, sweet, thank you. So again, guys, for this, the warm-up here, they want the exact value. These are all those quadrantal angles. So remember our rule with this one? If it's on the axis, and it's cosine, comma, sine. It really is that straightforward. So I'm trying to get you guys to notice there's kind of a pattern that shows up with this. And you still need to wait for me, that's fine. Just get attendance here and stuff. you want?
I
2.8 day 1. You showed me states, right?
yeah, I showed you another worksheet.
Yeah. You showed me 119 to 133. I know that. There's a 2.8 day 1 worksheet. Otherwise, I didn't show you. Here, you showed me the first half, yeah.
I did just finish.
Oh, and you're done now? Okay.
Yeah.
That went okay. That's fine. No, it's fine.
Haha, I found it.
Okay, good.
What? It's a read. Yeah, because Lana the section is reasons that we don't.
Trey, do you have 2.8 day 1?
Yeah. That's the. What is that one?
It says 2.8 day 1 on it. Sweet. Thank you. Yeah, no, you showed me so much. It's okay. Me too.
Yeah.
You have it?
I just have it in my notes.
That's fine. I'll just put it. Thank you. I just had it still. Yeah, I just wanted to be easy. Thank you. Yes. Were you okay on the warm up? Okay.
It's not like a bad thing.
Alright, so for our warm up here, this was going to get us to start thinking about the shape of sine and cosine graphs. So this warm up is meant to seem like it's kind of redundant because sine and cosine graphs are redundant. So like if you, guys, can you stop talking please? This pattern would continue over and over again, kind of like we were talking about when Trey said, well, can't you just add 360 onto that? Wouldn't the same thing happen again? And that would keep happening. It's cyclical. It has like a wave to it if you looked at the sine or cosine graphs at all. And so, and they don't really get all that, if we stay pretty basic, they don't fluctuate all that much. Oh, basic graphs here. So, so what we're getting this from, again, is what I just put on the board before.
Oh, sorry.
No, it's okay. What I was just putting on the board, I'm assuming I did something wrong.
No,
Is these quadrantal angles here. So kind of going from the 1, 0, and kind of going around that way. So starting with this sine of 0, so starting at that first axis, what's the sine of 0 going to be?
0.
Just 0. So you just want, remember when we're talking about this, this is cosine comma sine. So if I'm starting at my first one, then it's just 0 as my sine. So what's cosine at 0? 1. So basically our coordinate points are kind of like coming from there. And if you want, I didn't want you to check this, but if you check this in your calculator, if you check the sine of 0 or the cosine of 0, your calculator should give you 0 or 1 for that. Now, if you do 90, you have to make sure you're in degree mode. If you're in radians, it's going to give you a crazy answer. So right now we're talking about degrees, so that's what we should have it in. So when we spin up to 90 degrees, what does sine become at 90 degrees? 1. And what's cosine at that point? 0. So that kind of fluctuates that way. Now we're over at 180. 0 and -1. Because now we're to the left. Yep. 270, so we're down. So this is -1, and then this is 0. And then it repeats, right? So this would keep happening over and over and over again. This is what's getting us to start thinking about what these graphs should look like. So we're going to translate this now to is a little table. But if you notice if you look at the graphs that are there, they actually use radians instead of degrees. And so I thought it'd be good to talk about the difference between those two a little bit more and just make sure we kind of think about that as well. So the x coordinate is essentially the angle. And then this will be our y is our outcome. Now they started 0 as well, because 0 radians is still just 0. And it's like going back to our warm-up, and so we're talking about sine here. So sine of 0 is just going to be 0. So this graph would start at 0, 0. Now again, if you look at the graph on there, it's a little bit hard to see, but rather than using degrees, they use radians on the graph. So they have like pi over 2 pi, 3 pi over 2, 2 pi. So just kind of trying to review that a little bit with you guys so you're not too afraid of that when that comes up. So pi over 2 is the same thing as 90 degrees. And we just talked about that. What's the sine of 90? What did we just do in our top? Sine of 90 is what? 1. Yep. The next thing on our graph is pi, which is 180. And the sine of 180 is 0. 3 pi over 2 is the same as 270. That's going to be negative 1. And then when we've completed our whole cycle here, so 360 or 2 pi, those are the same thing. That's going to be back at 0, sorry. So if I go to graph this, do you want to make the first lumps 1 or do you want to go higher? So the first one's 1, that's okay. It's going to be a short little graph. So if I go to graph this, start at 0, 0. Then I go pi over 2 or 90 should be 1. Then pi should be 0. 3 pi over 2 should be negative 1, and then I should be back at 2 pi. So we get this cyclical graph, this wave, that would keep happening. So what happens then with cosine is it's basically just flipped of that. Or I guess a little bit different. Because sine starts at 0, cosine starts at 1 instead. So it's the same numbers, the same pattern, but it starts at a different spot. That one starts at 1. So then when I go to pi over 2, which is 90, that's going to be at 0. And that pattern continues. So this one now starts at 1. So similar wave, it just starts in a different spot. But it would still continue on forever. Can't decide if I'm hot or cold. Keep fluctuating. All right, so I do want you guys to try these in your calculator. I want you to practice sine and cosine in your calculator. But we have to figure out what settings to use. So that's what we need to kind of get used to. So if you, so like I'm just gonna write it down here. So like, I essentially want you guys to figure out, you're gonna put y equals sine of x in, and then y equals cosine of x. And we're gonna have to determine, like you can put them in together or separately or just one at a time, it's fine. But I wanted you guys to think about like what our graph should look like, and I'll show you guys a few different things that are kind of cool about a graph, and then some things that are kind of pesky about it that make it a little bit tougher. So it depends on the mode you're in, first of all. So, I should probably. So, first of all, depending on your mode, you might get something really weird if you, well, first of all, this shouldn't be what is happening. This is like another equation I had in here. But, so we just want to do like sine of x. And I kind of want you guys to see what that looks like, and then we can determine, do we need to change something about that? So that looks pretty okay. Did yours work out that way or no? No. What's wrong with yours? Anyone have an idea of what mode you guys could maybe be in that could be?
They're in degrees now.
Degrees. You could be in degree mode. Right now I'm in radians because that's my calculator defaults to when I turn it off. So if you're in degree mode, let me show you guys what that looks like, and that might be what's happening to yours, and so you might want to switch this, but I'm going to show you something else though too. Because in degree mode, this is what it looks like. Is that what happened to you guys?
Yeah.
Okay, why is that happening? Why does it look that way?
It's showing every single degree.
It's showing so this is talking about 1 degree, 2 degrees, 3 degrees, 4 degrees. Like, we don't really care about, we want to look at like all the way to like 100 or 360 degrees. We don't want to see like there's really nothing happening right here. So a few things you can do. One of them, there's a zoom, there's a trig zoom. What that zoom does is it takes you into like a trigonometry mode. So that's like one of the things I like to use. So zoom trig, that's one place. So if you don't get a graph you're expecting, that looks much nicer. So that one, I believe, like if I trace, I'm kind of curious as to what those are. I'm assuming that every line is 90 degrees. So if you look, yeah, if you look up at the top here, I'm at 90 and 1. So every line is 90. This is zoom trig. That works nicely. Yeah. Oh gosh, did you type sign in? How did you put it in?
I just put the same
And then did you use this X?
Yeah.
Do you have anything else on here that we have to? Oh, you were in some weird Zoom mode. Your battery's almost dead. All right. Now, this is if I'm in degree mode and I do that zoom trig. I can switch back to radians as well. Like radians should also work. Let me just show you guys that. Radians isn't a bad thing actually with graphing a lot of times. Now this one's still in that, now this is still in the same zoom it was just in where it's going like 90s. What I might do now, let's see. See if it trig now what it does. Yeah. Now when I do zoom trig, now if I go, I bet every line is pi over 2. So like that spot's gonna be pi, I bet. So getting used to these different modes and kind of playing with them, basically if you don't see what you want, trying one of these little tricks is gonna be a good idea. So here I'm really, really close to 0, and this is essentially just pi, 3.14. So that makes sense. Same thing should work with cosine. You can put cosine in the same graph. If you have different colors, it like lets you graph them different colors and it looks pretty. We're not going to do tangent today, but I might just throw it on there to show you guys a little bit of that. Come on. That almost looks like you have like 3D vision, or it's like some sort of like DNA strand or something. Are you guys getting that to work okay? Yeah? Okay. And it's a matter sometimes of like, you guys, there's times that I put it in and I'm like, what did I do wrong? Like, why is this not looking like a trig graph? Now that you know the shapes, they should like somehow look this way in some sort of way. So check those different settings if you're not getting it to work for you. Are you struggling there? Yeah, sometimes you have to have your computer open for it to know to charge. I have to open it a little bit. I don't know if that's doing it. Okay, now we're not going to do tangent in here, but I do want to mention it just because I think it's kind of interesting, math interesting, not like regular people interesting. But what do we talk about? Tangent, remember, is the sine over the cosine, or sorry, yeah, sine over cosine. So if I do sine over cosine here, what's tangent of 0? What's tangent of 0, guys? It's going to be 0, because 0 divided by 1 okay, so we're basically dividing these in the order you see them. So 1 over 0, what's tangent of 90 going to be? What's 1 over 0? Undefined. Now I want to show you guys what that means on this graph when that happens. So I'm going to show you that. Then here it goes back to 0. It doesn't sound like a very interesting graph. So this goes undefined again. And then back to 0. It actually is kind of a crazy graph because of the fact that undefined means there's probably an asymptote there. So it actually kind of goes a little bit wonky and crazy there. So if you didn't try it already, and like I said, we're not actually going to graph this as part of like our homework or anything, but it's worth showing. So it's kind of these like crazy like vertical squiggle lines. Anytime it's undefined, the graph like approaches that but never quite hits it. So like again, all these together is kind of cool. Separately by themselves, they're kind of interesting. Now some of you guys just draws a line in between there because it draws the asymptote, just like it did if it was horizontal. So if it has a line there, it just basically means it doesn't exist at that point. All right. What is your graph doing?
I have 7 functions going. But all like sides.
What's that? No,
That's
I
right.
don't think so. I think it would like flash or something if it was charging. You want to try putting in my little cube over there?
Sure.
I mean, just to see if it's.
Well, now it's red again.
Oh, so maybe it was charging.
I think orange is red.
Yeah.
Yes.
Operator error. Plug it in. Go close to a.
I'm ready for break.
You didn't operate.
Why did you have shoes on?
Well, I think it might.
Okay, that makes a little more sense.
Yeah, those got a pretty shoes
Okay.
I think orange is definitely.
Oh, the orange is charging. Okay, sorry, I didn't know.
I'll put it back.
What are your shoes?
There's a lot of questions here.
Get those socks.
Yeah.
What if I took my shoes off? Wouldn't that be weird?
They're on my bed.
What?
I didn't expect to get up.
answer is yes.
Yeah, it's weird. Because actually, yes, I heard that he did. that.
Well, I realized Stone was in here and I felt safe.
You felt like your pain would be violated. Oh my gosh. Sorry, Stone. Okay.
Dude, you should watch the video.
Okay. Becca said she needs a break, but I want to talk about the similarities and differences real quick with sine and cosine graphs before we move on, so that we kind of are thinking about it. So, basically, going back to these two graphs, or looking at the ones you have on your calculator, how would you, like, if you were trying to explain this to, you know, your parents who have been seeing sine and cosine graphs for a while, or little brother or sister, how would you explain, like, very simple differences and similarities between these? Maybe, like, where did they start?
One starts at the graph.
One starts in the middle of the arc.
Okay. So sine starts at 0. And cosine at 1. Okay. Anyone have anything else?
They're the same way.
They're the same way. So they do like the same thing, just starting at a different spot. So what makes them the same? What would make it like, what? Same, there you go, look at, listen to her, I wasn't even gonna go there. I'm, like maybe amplitude for the fancy people, or just like how high or low it goes, max or min, so the same max and min, does that sound better? So amplitude she's talking about, that's how high the wave goes. I mean, it's like a
Big person word.
big person word, big fancy. Other things, similarities, differences?
Nope.
That's about it.
I'm gonna write out one other thing with similarities is that it takes the same amount of time for it to complete a full cycle. So like, it's not like one over the course of 360 degrees, like, gets through it faster. It's the same like cycle. I guess I'm gonna write in better words. I can't think of a different way to say that. Oops, not cycle with this S, oh, the C. All right. So Becca needs a break, so we'll take a break.
Outside.
Outside?